Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Latifatul Luluah and I'm student of Industrial Engineering in 11 Maret University. I'm going to talk about my research which written with Professor Cucuk Rosyidi and Mrs. Azizah Aizyati. The title of the research is Optimization Model for Determining Order Quantity for Growing Item Considering Incremental Discount and Imperfect Quality. This is the outline of my presentation. First is introduction, then model formulation, numerical example, and close with conclusion. Introduction. In inventory control, companies need good planning in order to meet demand with minimal inventory cost. The method that is often used to determine the optimal order quantity is the economic order quantity method. But due to the limitation of the model, it cannot be applied to products with certain characteristics, such as goods that grow during storage. The assumption of constant weight must be relaxed. Such supplies are commonly found in the livestock, poultry, and fisheries industry. The assumption in the economic order quantity need to be relaxed in order to better describe the real system among them. 1. The assumption that all items produced are of good quality. In fact, not all items produced are of good quality. 2. Assuming the purchase price is always fixed. The supplier doesn't provide discount. Often, suppliers provide a reduction in the purchase price. 3. The assumption that item growth is always well developed. In fact, there is a possibility of it during the growing period. And next, system description. Based on the figure, the inventory system purpose in this research model consists of two periods, namely the growth period and the consumption period. In buying goods that are developing, suppliers offer additional discount, where suppliers provide a predetermined limit. At the time of purchasing newborn items, it was found that there were goods with less than perfect quality where the item purchased were of poor quality. The presence of an item of poorer quality can result in the possibility of the item being killed and the possibility that the item developed may last until the end of the growth period. Growth items that die during the growth period must be removed from the inventory system. After reaching the target weight, then the growing items are slaughtered and sold. During the consumption period, the amount of supply will continue to decrease until it reaches zero at the end of the cycle. And next, the following inventory system characteristics for growing items are depicted in the following graph. In this model, the objective function is to maximize total profit with the decision variable, namely the number of orders, the growth period cycle time, and the consumption period cycle time. And the assumptions used in this paper are as follows. 1. Only one type of item considered. 2. Demand is deterministic. 3. Items that are grown are immediately slaughtered at the end of the growth cycle. 4. All slaughtered items can be sold. 5. There is no excess production and shortage per cycle. 6. The product has no reproductive ability during the growth cycle. And 7. Food costs, storage costs are not only related to living goods, but also for dead-grown items until their death. And next, the notation used in the developed model is as follows. And model formulation. There is a probability of finding growing items with imperfect quality at the time of purchasing newborn item. So there are two possibilities, namely good quality, where all the goods that are grown can grow until the end of the growing period. Poor quality, where there are two possibilities, namely the first growing item can last until the end of the growth period and the possibility of the second growing item dying during the growing period. The growing item will be slaughtered when in the end of the growing period. The total weight at the end of the growth period must be equal to the demand to avoid shortage. Then, the duration of growth expressed as follows. And next, The costs involved in the model being developed are total revenue. Total revenue is obtained from total sales for growing items that live until the end of the growth period. Purchasing cost with incremental discount. The supplier offers an incremental discount for the purchase of item at the specified predetermined cutoff, where the purchase price gets smaller if the number of purchases increases. Feeding cost. Feeding cost is obtained from the cost of feeding multiplied by the weight of growing item that live until the end of the growth period. And holding costs. Holding costs are costs incurred while storing the growing items, consisting of holding costs for the growth period and the consumption period. And next, setup cost of growth period is the cost incurred for the purchase setup cost and during maintenance of the growing item. And setup costs of consumption period are used for the slaughtering process and other relevant costs. Disposal cost. Disposal cost is used to dispose of dead items during the growth period, and the total profit is obtained from the total revenue minus the total cost, where the total profit per unit time is obtained from the total profit divided by the cycle time. And the optimal order quantity for the purpose inventory system taking into account incremental discount and imperfect quality is obtained with the first derivative of the objective function equal to 0. Then we get the optimal number of orders with the following equation. Meanwhile, the optimal cycle time is calculated by substituting y to cycle time. And next, numerical example. To implement the purpose model, a numerical example is given to the poultry industry, where companies buy newborn chicken, then be fed, nurtured until they reach the target weight to be slaughtered and sold. The following are the parameter value used in the model and the purchase price range offered by the suppliers. And the algorithm used to obtain the optimal number of ordering solution and cycle time is as follows. Step 1. Calculate purchasing cost for each price break or price level offered. Step 2. Calculate YG for each purchase cost per unit. Step 3. Determine whether the YG obtained is feasible or not. YG is said to be feasible if YG is within the specified interval. If the value of y is not feasible, then the value of y is ignored. From the calculation result, the value of y2, y3, and y4 are feasible. And step 4 is calculate our cycle time of growing period value for every y that is feasible. And step 5 is calculate the cycle time of consumption period value for every y that is feasible. And last step is calculate the total profit per unit value for every y that is visible. The y value that produces the highest total profit is the optimal result. From the calculated result, it is found that y2 produces the highest total profit, so that y2 is the optimal result. And last conclusion. In this paper, we developed an economic order quantity model for growing item, where the weight of the item increases with time over a certain period. The model considered the incremental discount offered by the supplier and imperfect quality for purchasing newborn item to determine the quantity of the order to avoid shortage at the end of the growth period. And with the model developed in this research, it can be used as a reference for companies to determine the number of optimal order quantity to increase the profit of the company. And for future research, the inclusion of suppliers and other related parties will give a better solution in the supply chain of growing item by considering several aspects such as sustainability. That's my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.